Hi, welcome to Accelerated Engineering. I was thinking about this three variable system solver. I thought of a way that I could make it better. As a refresher, what this function does, well, we generated a function in a workshop previously. It gives us a Ohm's law solver for any, and you see that's linked over here. Any value that is missing from the three values put into it, it solves for. And any of those variables are missing, and it gets solved, which is nice. But I thought, well, what about this one here, where if it's given all three variables, this equation checks to see if it satisfies Ohm's law. I thought, well, that's good for simple numbers like this, but what if I've got something more complicated? Like instead of, what if 3.14159, something like that. Well then, what value needs to go in here? 6.28318, if I go 6.2832, which is pretty close, it's not gonna register that as being correct. If I use something worse, like actual pi, well, I'm never gonna get an answer that that satisfies this by guessing. And if I take this value, that's a lot of decimal places. It's more than I need. So I thought, let's add some precision requirements so that it can check within a certain range of a solution to Ohm's law, or within a certain tolerance of values, and so that it'll round off any really long outputs. As a super quick refresher, this lambda brings in the values for voltage, current, and resistance by being tied or being fed the inputs of other cells. It has an outputSelect that checks which values are present or are missing. It has an output that is determined based on the outputSelect using this switch function. And for all combinations of input variables, it has an equation or throws an error, because it's not solvable with inadequate inputs. Okay, how are we going to do this? Let's add one more variable called precision. And what I would like to do with that, well, let's say that for the solving options, I want to take my precision and I'll use that as a number of digits for a round function. So I would like to round this value off. We go to however many digits are indicated by the variable precision. And I think I'll do that for all of these, because that makes sense. It'll be even and consistent. Here we go. Resistance, precision, and that should be good. And if I don't feed it anything, let's see what it does if I don't give it anything. If I don't give it anything, I think it just assumes that the value is 0, so I'll get no digits past the decimal point. That works. I think that's reasonable. Although I might say, no, you know what? I'm going to leave it just like that. If I were to, well, let's tie this in properly. Get rid of precision. Let's say that I want 2 decimal places, and I'll take my lambda and give it that last variable, b6. There we go. I get 2 digits in the output. I can get no digits, and if I input a negative number, then I will get rounded off to the nearest 10. It just keeps kicking the decimal place. And I think that this will just give me 0. Yeah, that makes sense. Perfect. Perfect. That's good. I'm just going to put a really nasty number in here, square root of pi. I don't actually know what that does. Interesting. It gives me a rounded off number. If I want to go to a few decimal points, okay, perfect, that's good. Now what about in the case of that solver? I still want to use the value of precision, but I think I'll think about it instead as being a percentage of precision. So, well, what I would like to do is check if the voltage is within a certain range of the current times resistance. So I would like to say if the voltage is, I'm going to need two conditions because I'm going to need it between. So we're going to throw an AND bit of logic in here. If it is true both that the voltage is less than the current times resistance times 1 plus precision over 100. Okay, so that converts the precision to a percentage, divides it by dividing it by 100, and adds it to 1. So we're going to say if it is greater than, like if I put in a precision of 10 or 10%, it would take this value, multiply by 1.1, and say, is the voltage less than that? Okay, and I want it to be voltage, voltage greater than current times resistance times 1 minus precision over 100. That is the same thing, but it puts a lower bound on it. Have I closed all my parentheses? Nope, I need one more parentheses there. That would not work without it. And that's to close the AND function. That should work. I think I like that. Okay. So it says, based on the values that I've got input now with a precision of 3, I need a value of 7.875. So if I say 7.875, tells me indeed, we'll just ignore that, tells me that indeed this value is within the precision that I've specified, within the precision of 3%. Is it within the precision of 1%? It is. Is it within the precision of 0.1%? It is. What if I go 7.88, which is still pretty close? There we go. Not that precise. Let's see. Well, I did have it round before. So to two places it says 7.87, to one place it gives 7.9. If I put 7.9 in, it says that that's within tolerance, within 1% tolerance even. That's pretty good. That seems too good to be true, actually. Check my math here. Greater than current times resistance. Lower bound, less than current times resistance. Upper bound. Nope, that looks correct. So if I was just guessing at numbers, said put in 10%, how about, 9 volts is out of range. So that seems pretty fair. Oh, but look at that, it didn't round off. Yes, it did actually. It rounded it to 10 places of precision. If I go with 2, that's all fine and dandy. I can play around with this for a while, but anyway, get the gist of it. In the exact, well, that's interesting. In the event that it's an exact number or an exact ratio, then it doesn't extend out the extra digits of precision. I'd have to play with the number formatting to deal with that, and I don't really feel like that right now. Any which way, to push this back out to our Lambda function, I'll grab all this text and copy it, and edit directly my Ohm's law solver. Okay. Wouldn't let me hit OK because I missed the equal sign. There we go. Okay. Oh, why are you doing this? No. Okay. That's alright, I'll try it again. Grab everything from here to here. Control C. Name manager. Edit. Grab all the stuff. Backspace. Control V. Okay. My my new Ohm's law solver is up and running. And when fed all the inputs, it's done. And of course, if precision is not declared, it will just round off to the nearest integer number. Isn't that just lovely? If I want it to be within 10%, let's see. 3 times 6 is going to be 18, so if I feed it 17, it says it's within 10%. There we go. Ohm's law solver, now with extra precision. Anyway, that concludes my workshop. Let me know what you think in the comments. If you're looking for a workshop on something specific, let me know. Thanks for watching. Hope you're having a great day.